During this lesson, I'm going to go over the transformation of a quadratic from standard form to vertex form. The idea is to start from a quadratic equation written as fx equals y equals ax squared plus bx plus c, and transform it into an equivalent form, the vertex form, that it's written fx equals y equals a, that multiplies x minus h squared plus k, where h and k we know are the coordinates of the vertex and a is the scale. Just as a reminder, these two values are the same, both are the scale of the parabola described by both equations. In the standard form, we have c, that is the y-intercept, while in the vertex form we have h and k. They are, as I said before, the coordinates of the vertex. So both equations describe the same parabola, however they provide us with different information. So when, for example, we want to look for a maximum or minimum for a parabola, so we want to know the coordinates of the vertex, and we have the parabola in standard form, being able to transform this equation into a vertex form equation, can be extremely useful. Let's start with an example, and here we have y equals 2x squared plus 6x plus 8. The transformation is follows the same steps as the steps of completing the square. The only difference is that while we complete the square to find the roots of this equation, we set y equals 0, so we set this equation equals 0. However, in our case, we are not going to do that. In this case, we will just maintain the y, as we are just transforming from one equation to the next. The first thing I'm going to do is to rewrite this equation as 2x squared plus 6x equals y minus 8. I'm going to what I did, I just moved the constant term to the right of the equation, and again notice that I kept y on this side of the equation. The next step will be to assure that we have the multiplier or the coefficient of x squared as 1. So to do that, I need to divide the equation, both sides of the equation, by 2, so that I can simplify the coefficient of x squared to 1. So if I do that, I can rewrite this equation as 2 divided by 2x squared plus 6 divided by 2x equals y divided by 2 minus 8 divided by 2. And this can be rewritten as x squared plus 3x equals 1/2 y minus 4. Okay, we are halfway towards the transformation. The next step is to focus our attention on the second term, on the second coefficient, the coefficient of x. And we are going to isolate that coefficient, and we are going to divide it by 2. So we divide the coefficient by 2 and we obtain 3 divided by 2. And then we are going to square this coefficient. So this becomes 9 divided by 4. This term right here, that is actually our the missing piece to complete the square. So if I add this to this binomial on both sides of the equation, I can obtain a perfect squared trinomial. So if I rewrite this as x squared plus 3x plus 9/4 equal 1/2 y minus 4 plus 9/4, I know now that this is a perfect trinomial, a perfect square trinomial that can be rewritten as x plus this term right here, 3/2 square equals 1/2 y, and if I sum this up, and let me rewrite this side of the equation as 1/2 y minus 16 divided by 4 plus 9/4, and this becomes minus 7/4. Here you go. I have basically completed the square here, and I have here a square binomial. The transformation is basically over. The only thing that I have to do now is a little bit of rearranging of terms. I need to move this term to the left again, and then I need to multiply everything by 2, both sides of the equations by 2, so that I can simplify my I can get a straight y on the side of the equation, and I can get to this form that I wanted from the very beginning. So let's do some manipulations here. First, let me move this term to the left, and so I can rewrite everything as x plus 3/2 square plus 7/4 equals half y, and then let's multiply everything by 2 so I can get rid of this 2. I can rewrite this equation as y equals 2x plus 3/2 square plus 7/2. Here we go. This is my completed transformation. This is my vertex form of this equation, where we started. So now I know that the vertex of my parabola, of the parabola described by this, is actually minus 3/2 and 7/2. So the coordinates of the vertex can be rewritten as minus 3/2, 7/2. Remember the minus sign, because the formula has a minus h here. So if this term is positive, it means that the original x was negative. So these are the coordinates on my parabola. If I were to draw my parabola at this point, I will have something that looks like this. Alrighty. Okay, these are my axes, x and y. The parabola will open up as I have a positive scale 2. My vertex would be here, and this is 7/2 and minus 3/2, and my y-intercept will be at 8. Remember that C here is my y-intercept, and my y-intercept in this case would be 8. So we have basically found quite a bit of information regarding our parabola, because we have the vertex, we have the coordinates of the vertex, we know how it opens, we know the scale, and we also know the coordinate, the y-intercept coordinate. The next step would be to find the symmetrical point to the y intercept, and it will be subject of another lesson.